In this video, I have identified 6 geological structures scattered throughout the great and diverse expanses of North America. This collection includes massive monoliths, the remnants of prehistoric seabeds, ancient impact craters, and many more. There was no strict criteria of selection for these sites. Rather, this is a collection of little-known geological structures that have struck me as intriguing due to their anomalous formations and fascinating historical contexts. The first site takes us deep into Appalachia, to the small, unassuming city of Middlesboro, Kentucky. Despite being the largest city in southeastern Kentucky, Middlesboro only boasts a population of around 10,000, with its greater micropolitan area population being just under 70,000. Although it may seem like your run-of-the-mill mid-sized Appalachian city, Middlesboro actually sits directly within the confines of the remnants of an ancient meteorite impact crater. The crater measures 3 miles, 4.8 kilometers, in diameter, with the city of Middlesboro lying entirely within its surface area. Despite the city being founded in 1866, the unique nature of the surrounding basin was not uncovered until 1966, when sandstone shatter cones and shocked quartz were identified in the area. Shatter cones are a rare geological phenomenon that occurs when bedrock is subjected to high-pressure events, such as meteor strikes or underground nuclear explosions. When these rocks are exposed to shock with pressures of 2 to 30 gigapascals, or 290,000 to 4,350,000 pounds per square inch, they develop unusual, striated, and horse-tailed conical fractures, which can range from microscopic scale to tens of meters in length. Shocked quartz is a similar phenomenon. However, the quartz's crystalline structure experiences deformation along planes. These two abnormalities allow geologists to identify whether a given geological structure is the result of a meteorite impact rather than other processes, such as volcanic activity. The underlying cause of this basin's formation may not have been discovered until relatively recently, but the process that formed it has greatly affected both the city's foundation and its socioeconomic development since its inception. Middlesboro's creation was due to its strategic location in proximity to the Cumberland Gap, a natural pass through the Appalachian Mountains that was heavily utilized as a key passageway for colonial Americans. The Cumberland Gap is one of the few ways to traverse the lower central Appalachians, and its use was integral to the settlement of the then western frontiers of Kentucky and Tennessee. It's interesting to imagine how profoundly different this region might have developed if an ancient meteor hadn't carved a perfectly located basin that permitted the migration of countless people. And it's even more astounding to think about all the people who likely lived and died throughout this quaint little valley without the slightest idea that they were in the remnants of a prehistoric impact crater. Moving westward to the Basin and Range region of the United States, the next site is the McDermitt Caldera, which sits directly on the border between northern Nevada and southern Oregon. A caldera is a large, usually circular, depression in the earth, created when a volcano's magma chamber empties in a major eruption and the structure collapses inward on itself. In simpler terms, think of it as the corpse left behind by a dead volcano. The McDermitt Caldera is an anomaly for 2 separate yet fascinating reasons. The first reason is that this 28 by 22 mile structure is theorized to be the very oldest in the caldera sequence created by the Yellowstone hotspot. This means that the very same hotspot that created this structure is now the Yellowstone caldera in the national park of the same name, approximately 400 miles to the northeast. The McDermitt Caldera was formed by this hotspot roughly 19 million years ago and collapsed 16 million years ago. As time progressed, the North American plate gradually shifted, causing the McDermitt Caldera to migrate southwest of the hotspot's location. This process also created the younger structures of the Island Park Caldera, Henry's Fork Caldera, and the Bruneau-Jarbidge Caldera in this sequence. This process also formed the Greater Snake River Plain, a topographic depression cutting through and notably deviating from the typical topography of the Basin and Range region. When viewed from this perspective, it's incredible to see how massive the Yellowstone Plateau volcanic field is and how the seemingly rudimentary structure of the McDermitt Caldera is actually the ancient remnants of this colossal volcanic hotspot that rages on to this day. The second and quite possibly more intriguing aspect of the McDermitt Caldera is its geologic composition. Once the lava dome of the volcano collapsed, a lake subsequently formed within the caldera. This caused a very rare geological phenomenon in which much of the lithium-rich volcanic ash was deposited on the lakebed and released gases and briny solutions that mixed with the hydrothermal fluids of the underlying magma chamber. This eventually led to the accumulation of a very rare form of lithium-rich clay deposits at the lakebed. The result of this complex process is that the McDermitt Caldera has massive lithium reserves, the scale of which is not yet fully known. However, it is likely one of the largest deposits discovered on Earth to this day. Let's take a quick pause to talk about lithium for a second. Lithium is classified as a critical mineral due to the fact that it is an integral resource in nuclear physics, medication manufacturing, and industrial manufacturing. Most notably for power grid storage systems, as well as being an intrinsic component in lithium-ion batteries, which are currently fueling the global EV booms. Despite all this, high-concentration lithium deposits on Earth are relatively rare. The majority of global lithium production currently comes from Australia, China, and Chile. Australia and China predominantly mine from spodumene reserves, a lithium-dense form of rock, while Chile mostly derives lithium from processing brine pools within salt flats. The lithium-rich clay deposits within the McDermitt Caldera represent a largely unexplored form of lithium extraction. However, if the U.S. is capable of creating a cost-effective way to extract from these deposits, the McDermitt Caldera could become a profoundly useful source of this important resource for the United States strategically. Thacker Pass, a spiritually significant area for local indigenous tribes due to it being the site of a massacre in 1865, just so happens to be where much of these sedimentary lithium clay deposits are located. Geologic surveys of the area calculate that 3.7 million tons of lithium carbonate equivalent are stored in the sediments, totaling nearly $4 billion USD in recoverable lithium deposits, making it easily the largest discovered lithium deposit in the United States. Because of this, and the strategic value of having domestic lithium production, the Bureau of Land Management issued a record of decision approving development of the mine in January 2021, despite heavy protests from local indigenous populations. Construction on a state-of-the-art plant implementing newly invented tactics to extract from the lithium-rich clay deposits started in 2023 and will likely begin operation in the next year. At a glance, the McDermitt Caldera looks like any other dry and desolate mountain scattered throughout the basin and range region. But now that we've done a deeper dive into its geologic history and composition, what's unveiled is an ancient collapsed volcano that is the oldest remnant of the Yellowstone hotspot and also happens to have massive reserves of a critical mineral stored in a rare clay-based form, which could potentially bring the United States to the forefront of global production of this essential resource. When I say the word mesa, you are likely struck with thoughts of a harsh yet beautiful desert environment. Maybe you think of the Grand Mesa of western Colorado, or possibly Monument Valley in Utah. However, I want to take you to a mesa located on the opposite side of the continent, in Canada, of all places. The Sleeping Giant is a colloquial name for a series of mesa and sill formations that lie east of Thunder Bay, Ontario, at the southern end of the Sibley Peninsula. This tableland structure is massive and protrudes sharply against the vastly flat surrounding landscape of the Canadian Shield. The igneous rock that makes up this complex is much more resistant to erosion, and therefore, as the surrounding landscape has been weathered down, this massive mesa remains steadfast in its grandeur. The cliffs measure 240 meters, making them the highest in all of Ontario. The mesa structure itself is made of diabase sills, a rock complex covered by Paleozoic sedimentary rock, mostly granite and gneiss. The rock that constructs this tableland cover is 1 billion years old, making it some of the oldest on Earth. This structure is an anomaly because the Canadian Shield is a region characterized by a flat, endless expanse of exposed rock, with many lakes but few mountains to speak of. This area of Ontario is well known for such characteristics. The structure assumed its colloquial moniker due to the fact that, when viewed from the west to northwest section of Thunder Bay, the mesa's outline appears to resemble that of a giant man. Moreover, when viewed from the cliffs at Sawyers Bay, the giant seems to distinctly have an Adam's apple as well. The reason for this structure being where it is comes down to the fact that it lies directly on the boundaries of an ancient rift valley, the Mid-Continent Rift System. When the rift failed, much of the igneous rock was exposed in the northern areas of this region, which was subsequently barely affected by the periods of glaciation that flattened much of the upper Great Plains and Canadian Shield. Staying on the topic of mesas, This next site takes us over the Great Plains and into the Rocky Mountain Plateau. Fossil Butte National Monument. This tableland rises over 1,000 feet above the surrounding plateau. Atop this massive mesa lies one of the most pristine and well-preserved fossil assemblages in the world. Roughly 34 to 56 million years ago, during the Eocene epoch, this landscape looked vastly different. Instead of the arid, mountainous region we see today, the area was dominated by a massive ancient lake system. Much of what is now southwestern Wyoming, northeastern Utah, and northwestern Colorado was once submerged beneath three interconnected lakes collectively known as the Green River Formation. These included Lake Gossiute, Lake Uinta, and Fossil Lake, the latter being the preserved lakebed atop Fossil Butte. Over millions of years, the lake system accumulated fine-grained sediments, including limestone, shale, and mudstone, all rich in organic material. These sediments eventually lithified, forming the rocks that now make up the Green River Formation, with Fossil Butte as one of its most prominent remnants. Fossil Lake was a relatively small but deep subtropical freshwater basin that teemed with life. Fossils uncovered at this site include a stunning variety of faunas, such as fish, alligators, bats, turtles, insects, and even an ancient species of horse no larger than a modern dog. This small equine, known as Protorrhohippus venticulus, or the dawn horse, is among the most fascinating discoveries. Fossil Butte is renowned for the unparalleled preservation of its fossils. The fine-grained limestone captured extraordinary details, including scales, feathers, and even soft tissues, offering an unprecedented glimpse into Eocene ecosystems. Unlike many fossil sites, Fossil Butte represents a complete lacustrine environment, encompassing everything from algae to top predators. This makes it an invaluable ecological snapshot of life during the Eocene epoch. Traveling to the southern reaches of the continent, our next site takes us to the Bajío region of the Mexican Plateau. The town of Bernal, Mexico, is a quaint colonial village whose name derives from a Basque word meaning place of stones or boulders. With a population of just under 3,000, Bernal, like Middlesboro, is profoundly shaped by a unique geologic anomaly nearby. Towering 1,421 feet, 433 meters, above the town is a stone monolith known as Pena de Bernal. This massive porphyritic rock is the third largest monolith of its kind in the world. Pena de Bernal is an ancient igneous intrusion, the crystallized core of an extinct volcano. Just as the McDermitt Caldera can be seen as the remains of a dead volcano, Pena de Bernal represents the crystallized heart of one whose outer structure has long since eroded away. This dacitic dome structure, estimated to be around 8.7 million years old, highlights a fascinating distinction. Extinct volcanoes that erupt often leave behind calderas, while those that don't typically form volcanic plugs. Pena de Bernal lies within the Trans-Mexican Volcanic Belt and the Sierra Gorda region, areas shaped by significant tectonic activity linked to the subduction of the Farallon Plate beneath the North American Plate during the Mesozoic era. This subduction generated widespread volcanic and magmatic activity, leading to the formation of intrusive igneous bodies like Pena de Bernal. As a volcanic plug, it originated from magma that intruded into surrounding sedimentary rocks but never reached the surface. The magma slowly cooled underground, forming a large mass of igneous rock, primarily composed of rhyolite and dacite silica-rich volcanic rocks, renowned for their resistance to weathering. Over millions of years, erosion stripped away the surrounding softer sedimentary rocks, leaving this massive isolated monolith exposed. Pena de Bernal's prominence and grandeur invite comparisons to iconic geological formations, like the Rock of Gibraltar on the southern edge of the Iberian Peninsula, and Devil's Tower in Wyoming. Adding to its allure, Bernal's colonial roots and strong Catholic heritage have made the monolith a site of religious significance. A chapel at its base has become a popular pilgrimage destination for devout Catholics from Mexico and beyond. Staying on the topic of volcanic plugs, our final destination takes us to California's central coast. San Luis Obispo is a town many of you have likely heard of. Originally founded in 1772, with the establishment of Mission San Luis Obispo de Tolosa, the region experienced exponential growth after the American conquest of California. Today it's best known as one of the nation's premier college towns. With its idyllic Central Coast scenery, expansive vineyards, and, most notably, the presence of California State University, San Luis Obispo, the town attracts tourists and students alike. Located just 11 miles inland from the California coast, San Luis Obispo is nestled in a small valley flanked by the Santa Lucia Mountains to the north, south, and east. This creates a trough-shaped valley that leads to the sea, ending in the coastal town of Morro Bay. Running parallel to this valley is a system of hills distinctly separate from the surrounding mountains, known as the Nine Sisters. What makes the Nine Sisters so captivating is their geological origin, which ties together two concepts explored earlier in this video: hotspots and volcanic plugs. Similar to how the McDermitt Caldera is a remnant of the Yellowstone hotspot, which left multiple calderas in its wake along the Snake River Plain, the Nine Sisters were formed by a similar, though much smaller, hotspot. Unlike the Yellowstone hotspot, which created calderas, the hotspot responsible for the Nine Sisters left behind volcanic plugs, much like Pena de Bernal. The Nine Sisters formed when magma intruded into the Earth's crust but never erupted. Instead, the magma cooled and crystallized into hard igneous rock, primarily diorite and andesite. This formation occurred during a period of tectonic activity along the San Andreas Fault System during the Miocene epoch. Tectonic plate movements caused crustal stretching and thinning, allowing magma to rise and form intrusions that became the Nine Sisters. The faulting and folding associated with this tectonic activity influenced the alignment of these volcanic plugs, which follow a roughly northwest-southeast trend along the San Luis Obispo Trough Valley. Although commonly referred to as the Nine Sisters, this chain of volcanic plugs actually includes 23 distinct structures. However, only 9 are typically highlighted due to their prominence. Starting on the eastern end of the valley and moving toward the Pacific, the Nine Sisters are Islay Hill, Cerro San Luis Obispo, Bishop Peak, Chumash Peak, Cerro Romualdo, Hollister Peak, Cerro Cabrillo, Black Hill, and Morro Rock. Morro Rock is perhaps the most intriguing of the Nine Sisters. Not only is it the final and smallest formation in the chain, but it also sits directly on the Pacific coastline. This unique location makes Morro Rock a popular tourist destination in Morro Bay, as well as a sacred site for the Salinan and Chumash tribes. It's fascinating to think about how many people have admired this stunning natural landmark without realizing it's the final remnant of an ancient volcanic hotspot that shaped the many hills dotting the San Luis Obispo Valley. This wraps up our list, and my very first YouTube video. I'd love to hear from you in the comments. Have you heard of any of these geological anomalies? Did I miss any fascinating details about these sites? Let me know! Also, feel free to share other geological structures or regions you think I should check out. I'd be thrilled to spotlight some of your recommendations in future videos.